Alright, this is going to be a tutorial on factorizing over the complex field, and to show this we're going to be using an example. The example is going to be y squared plus z squared plus 2z plus 2 equals 0. We're going to factor this over the complex field. So for this particular example, we're going to use completing the square. And if you remember correctly, this a, because a x squared plus bx plus c equals 0 form, that's what we're using. It's bx plus c equals 0. So we have to have a equal to 1. It is in this example, so we can use completing the square right now. And if you remember, we also have to take the b coefficient, half it, or half of 2, and we take that, 1, and we square it. The next step, what we're going to do is we take z squared plus 2z, and we add what we just found, 1 squared, or 1. And that's a part of the expression now. And to counteract that, we subtract 1. And don't forget our plus 2, we put that in there, and this is all equal to 0. So we can factor this now very easily, and that is z plus 1 times z plus 1, or z plus 1 squared. And outside of it, we have 1. And this is equal to 0. Plus 1. So to factor this over the factorize over this over the complex field, what we do is we take this 1 and we 1 in complex terms is equal to negative I squared. So we can substitute that right here, and what we'll get is z plus 1 all squared minus I squared equals 0. Now what we can do is we can factor this into factors. And what we get is 1 factor z plus 1 plus I. And the other factor is z plus 1 minus I equals 0. Now simply what we have is the factors for this equation, and we set them equal to 0. So y plus 1 plus I equals 0. Z plus 1 plus I. Z plus 1 minus I equals 0. And we solve. So we subtract both sides. We subtract this from both sides. Z equals negative 1 minus I. There's our answer for 1. And z equals negative 1 plus I. There's another answer. Now, notice that these are both conjugates. And that's how you factor over the complex field.